The production possibilities frontier. This is a curve depicting all maximum output possibilities for two goods, given a set of inputs consisting of resources and other factors. The PPF assumes that all inputs are used efficiently. Suppose you live on an island that has only birds and berries. To survive, you can choose between hunting birds, picking berries, or both. Let's list out the possible scenarios for your survival strategy. Scenario A. You spend all time hunting birds and not picking any berries. You are able to catch 5 birds using all available resources. Scenario B. You divide your available resources to catch only 4 birds and spend the rest of them picking berries. In doing so, you get 200 berries. We are assuming that all other factors and resources remain the same. You are not changing your tools to catch the birds. The weather on the island remains the same. You are not sleeping less to hunt birds and pick berries. With other conditions being equal, we call this ceteris paribus. Scenario C. You catch 3 birds in total and you increase your berry pickings to 320 with all else remaining the same. Repeat this to the next scenario and then the next. For each new scenario, reduce your bird hunting by 1 count, and you arrive at the following table. This table shows the different combinations of two goods that can be produced, using full employment of resources. Plotting onto a graph, this is how the curve looks like. This is the production possibilities curve, or production possibilities frontier. This curve shows 4 key economic concepts. These are scarcity, trade-off, opportunity costs and efficiency. Number 1, scarcity. Let's move to a point on the right side of the PPF. This red point depicts a combination of 6 birds and 600 berries, which is an output you will not be able to achieve under the given resources and conditions. You cannot produce at any point beyond the curve. The PPF shows that you have limited resources and demonstrates the concept of scarcity. Number 2, trade-off. The PPF shows trade-off. Without any shift in the curve, if you decide to catch more birds, you need to give up some berries, or if you decide to pick more berries, you need to give up some birds. This happens when you move along the curve. Number 3, opportunity cost. Opportunity cost is the measure of trade-offs in quantifiable terms. It is what you are giving up in order to get more of something else. When moving from scenario A to E, we are losing 4 birds and gaining 460 berries. Hence the opportunity cost to move from A to E is 4 birds. When moving from scenario E to B, we are gaining 3 birds and losing 260 berries. So the opportunity cost of moving from E to B is 260 berries. Number 4. Efficiency. Any point on the left-hand side of the PPF represents a combination of output that you can achieve below your maximum utilization of resources. Let's move to a point on the left-hand side of the PPF. Here, you have a combination of 2 birds and 200 berries. At this point, there is inefficient use of resources, because you can have the same number of birds and more berries at point D, or same number of berries and more birds at point B. At B and D, you fully utilize your resources to achieve the maximum output possible. Any point on the PPF is efficient, and we call this productive efficiency. Productive efficiency is concerned with producing goods and services with the optimal combination of inputs to produce maximum output for the minimum cost. To be productively efficient means the economy must be producing on its production possibility frontier. Opportunity cost and marginal cost. When we express opportunity cost in terms of producing 1 more additional unit of a good, we get the marginal cost. Marginal cost is the cost resulting from producing 1 additional unit of a product or service. When we move from scenario F to E, the opportunity cost of increasing 1 additional bird is 20 berries. This means that the marginal cost is 20 berries. Moving from scenario E to D, the opportunity cost of increasing by 1 bird or marginal cost from E to D is 60 berries. Moving from scenario D to B, the number of birds increases by 2. The opportunity cost is 200 berries. The marginal cost, which is the opportunity cost of increasing by 1 bird, is 200 divided by 2, or 100 berries. Conversely, if we move from scenario D to E, we gain 60 berries more but lost 1 bird. The the opportunity cost is 1 bird and the marginal cost is 1 of a 60th bird, or 1 divided by 60, the shape of the production possibilities frontier. Consider an economy which produces only two types of goods, X and Y. There are three ways to draw the production possibilities frontier. These are 1. Straight line, 2. Convex or bowed out curve, and 3. Concaved or bowed in curve. For the straight production possibility frontier, the opportunity cost of giving up 1 unit of X is always consistent, and this is measured by the gradient or slope of the PPF. This is regardless of which scenario, or point you are at on the production possibility frontier. For the case of the convex or bowed out curve, the opportunity cost increases for every additional unit of a good produced. For the first unit of X produced, the opportunity cost in terms of Y is the quantity marked A. The next unit of X produced, the opportunity cost becomes B. And the next unit of X, the opportunity cost becomes C. Notice that we are giving up more and more units of Y as our production of X increases. This is known as the law of increasing opportunity cost. For a concave or bowed-in curve, the opposite happens. The opportunity cost of producing X decreases with the increase in the production of X. The concave PPF does not follow the law of increasing opportunity costs. In reality, straight-line PPF and concaved PPF are very rare. The bow-out or convex PPF curves more accurately depicts the economic reality. If X refers to the manufacturing of cars, and Y refers to the baking of bread, we would expect the PPF to be a bowed-out curve. The technologies used to build cars and bake bread are very different. This makes it very difficult to switch from making cars to baking bread. The law of increasing opportunity costs kicks in, giving us the convex shape of the PPF. If we replace baking bread with manufacturing buses, the new PPF curve to be less convexed, or flatter than the curve before. The technologies to manufacture cars and buses are similar, making it easier to switch from producing cars to buses.